This is lesson 0.1. Yes, 0.1 because it's a review lesson. These are topics that you need for the AP Calculus course that you should have learned in your pre-calculus courses. And we better do a review so that you can have the tools to be ready to do well in the course. Now, one of the things that we'll talk about quite a bit is this thing called slope. And yes, you've seen this before, and that's like the steepness of the line. The letter that mathematicians most likely use to represent slope is M, and the definitions that you hopefully have seen is this rise over run, or perhaps this with the coordinates y2 minus y1 over x2 minus x1, or even this notation of the triangle, which represents the change in the y over the change in the x. I know most textbooks use this lovely definition here, so I came up with a little jingle to help you memorize this. I don't know if you've done it before or heard it before, but if you do know the song Row, Row, Row Your Boat, this is actually verse 2 of that song. So it says, slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So if you like that song, go ahead and use it. If you don't, then just delete that from your memory. But what I'd like you to do is look at these examples, numbers 1, 2, 3, and 4, and let's see if you can find the slopes of these lines that contain each pair of points. So in this case, if you look at number 1, we have this lovely point here, and this one here. We can use any of the definitions from above, but this time I'm going to use this idea of the change in the y. And if you look, it looks like the change in the y goes down 4 units for every 1, 2, 3 units to the right. And if you think about what that slope would be, then yes, it'd be 4 down, or negative 4, 3 to the right, a positive 3. So negative 4/3. Number 2 actually gives you coordinates, so yeah, I'll just use my song. Slope equals, and once again, you have to figure out what x sub 1 and x sub 2 is. So I'll just go x sub 1, y sub 1 for the first coordinate, x sub 2, y sub 2 for the second one. So slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Be careful, minusing a negative. So that's 2 take away, or 2 divided by 6, and yes, you can simplify that to 1/3. Beautiful. I'm going to get you to try number 3 and number 4 yourself, okay? And then I will do it as well. Come back and double check your answer with mine, please. Begin. Yes, if you found that the slope here is 0, that makes total sense. If you actually graph out those 2 points, let me quickly do it. You don't need to, but I will. 1, 2, 3, 1, 2, and then 2, 2. You'll see that this is a nice horizontal line, and I hope you remember that horizontal lines have slope equal to 0. And in this case, we have an undefined slope. Can't divide by 0. But if I were to graph out these points, 1, 2, 3, 2, 3, 5, you'll see that they are vertical, and yes, slopes of vertical lines are undefined. Okay, so I'll just make a quick note, vertical line, and then for number 3, horizontal line. Good. You should have also remembered that parallel lines have equal slopes, and perpendicular ones have slopes which are opposite reciprocal, so don't forget you flip it, what's the reciprocal part, but many forget the negative as well. And here are 2 examples of perpendicular lines. Notice m sub 1, which is this one, has a slope of 5/2, where the slope of m sub 2, which is a perpendicular line, would be the flip, which would be 2/5, and don't forget the opposite with a negative. You also should have seen 3 different forms for the equation of lines. Yes, 3 different forms. The point slope form is the one that I think is most commonly used in AP Calculus. The slope point form is the one that many people learn in pre-calculus. The general form just looks nice, but doesn't really tell you much information. But nonetheless, you should know all 3 forms. So looking at that, can you try examples 5, 6, 7, and 8? We'll do a few of them together. So find an equation of each line described. So if I said an equation, it doesn't matter which format, you can choose. If I get a information with a point and a slope, yeah, I'm going to use the point slope form for sure. So if you think about the 2, that's my x sub 1, and my 3 is my y sub 1. So I'm just going to quickly use the point slope formula here. Y take away 3, m is negative 3, bracket x minus 2, and actually I'm done. Now for those of you who like the slope-intercept form, then of course you could just go ahead and expand and simplify and all that kind of stuff to get it into that form. But I'm not going to do that. Not this time. How about a vertical line? Ooh. A vertical line. I'm going to visualize this and draw it out. Negative 1, comma 2. So a vertical line would be something like this. And notice that what is the same for all the points on a vertical line? And if you said, yes, the x value is the same, you are correct. And so therefore, I just need to use one variable here to represent this line. X equals to, that's right, negative 1. Done. All right, let's do number 7. I've got a point again. Ooh, thinking point slope form. Yeah. Ooh, I need a slope. And it says, ooh, it's parallel to the graph of this equation. So we know from above that parallel slopes, or parallel lines, have same slope. So how can I figure out the slope here of this equation 2x minus 5y equals to 5? Perhaps I'll rewrite this in slope-intercept form. Negative 5y equals to negative 2x plus 5. We'll continue to isolate y by dividing every single term by negative 5. So that's 2/5 x minus 1. And lo and behold, we have our slope-intercept form, so therefore the slope m must equal to 2/5. And since it is parallel, the other equation must also have a slope of 2/5. So therefore, it says I want slope-intercept form. So y equals mx plus b is what I'm going to use this time. We know that the m, or the slope, since it's parallel, must be 2/5. And now we have to figure out b. How can we figure out b? We'll actually plug in the point, because that's a point. That means it's an x and y coordinate that's on this particular line. Plug it in. And just do some quick algebra here. We'll find out that b is equal to 2 and 2/5. If I wanted to rewrite that as an improper fraction, that's 12 over 5. So y equals to 2/5 x plus 12 over 5. Did you get that? I hope so, because that's the right answer. Okay, and so number 8, I'm going to ask you to try on your own, because it's very similar to number 7. The only little trick here is I've changed one of these words. Instead of having parallel, it's now perpendicular. So go ahead and try that yourself, and then check your answer with mine when you're done. Press pause. So same equation from number 7, right? So from number 7, we know that this slope equals to 2/5. Therefore, the perpendicular slope, I'll go m with a little perpendicular here. That must be negative 5/2. That's right, the flip and the opposite. We want in general form this time, so it doesn't matter if we use slope intercept or point slope form. I'm just going to use point slope form first. Y minus 2 equals to negative 5/2 bracket x minus negative 1, which is of course x plus 1. We need to expand and simplify because there are no brackets in general form. There are also no fractions in general form. So how about multiplying everything by, oops, what did I just press here? Multiply everything by 2. That's good. Remember, everything by 2. 2y minus 4. negative 5x, take away 5, and then move all the terms to one side, and voila, your equation in general form. Nice, 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 nice. Okay, so this is a good review of lines, slopes, all that stuff you learned in pre-calculus. You should also be able to draw a graph of each line, so I don't know if you remember which ways you can figure this out, but there are two general ways. I'll show you both for number 9. Method number 1 is to find the intercepts, that's both x and y, and then once you have 2 points, because this is a line, you can connect them together, and there you go. So if I wanted to find the intercepts, to find the x-intercept first, the idea is you let y equal to 0. So if I did that, I get 2x plus 3 times 0 equals to 9. 2x equals to 9, or x equals to 4.5, 4.5. Okay, so 1, 2, 3, 4.5, something like that. We can then also find the y-intercept. In this case, you let x equals 0, so 2 times 0 plus 3y equals to 9, and y equals to 3. So I can plot that point now, where x is 0, y is 3. And like I told you earlier, let's connect the dots, and there you go. Done. Now, if you thought that was a little bit too cumbersome, or you're like, oh, I don't like all this solving stuff, okay, well, method number 2 would be to use one of the nice equation to line formats. I actually like the one that's slope y-intercept because it tells you the slope, yeah, and it also tells you the y-intercept, and then you can plot and graph it out that way too. So method 2 would be actually to change it into slope intercept form. And to do that, you have to isolate the y variable. So once again, I'm copying the equation. I'm asking us to solve for y, so I'll move the 2x to the right hand side. And then finally, to solve for y, we'll divide everything by 3. 9 divided by 3 is 3. And so now from here we see that the slope is negative 2/3, which means you go down 2 each time you go right 3 units. And this plus 3 here is the y-intercept, which makes sense because that's what I also got over here. So we'll take the y-intercept, and then in this case down 2, 1, 2 for each time you go 3 to the right. Oh, beautiful. This point here too, and yeah, we get the exact same curve. So 2 different methods to do the same thing. It's up to you which one you like. Choose your own adventure. Okay, now what about number 10? That's kind of weird. What happened to the x? It's only y equals 2. What's going on? So remember how above in, I think, question number 6, yeah, we had this thing called a vertical line, and we said all the vertical lines have x values that are the same. So what would you predict this line would be if y equals to 2? Y equals to 2 right here, also here, also here, also here, also here, also here, also here, everywhere along here. So I hope you can just draw a nice horizontal line, and that is the graph of the line y equals to 2. So a horizontal line is always y equals to blah 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 blah, right? And notice above here, x equals 2, this is always a vertical line. So get that into your head. Alright, slopes and lines, I hope that was a good review, because next page is, it's time to bring out your calculator. And for the AP Calculus course, you will definitely require, yes, need, yes, must have a graphing calculator. Okay, they will actually not allow you to use a scientific calculator on the AP exam. So you got to know how to use one of these things. Well, if you don't have one right now, you got to get one of these things. So make sure you can find one, and then make sure you know how to use it. I'm going to be using the TI-83 for this course. You can use the souped up TI-84 or anything else, but make sure it's one of the approved calculators for the exam. So here's number 11. It says, find a window to show a complete graph of this function. So if you're just going to be like any student and say, hey, I'm just going to plug this in, y equals 2, and let's see what happens, by all means, you can. But remember, the idea is I want to show a complete graph. So you do need to use some pre-calc 12 info to really think about what do I mean by a complete graph. So I've plotted the equation in my y equals to screen. I'm going to actually take it and use my zoom standard. That's the window that has negative 10, 10, negative 10, 10 as the x mins and y mins. And you're like, great, this looks like a parabola, I'm done. And your pre-calculus mind should say, hold on, is this the complete graph? Is this really a parabolic equation? And you should be saying, no way, because yes, we have the power of 3. So this is a cubic function. A cubic function either looks something like this, or let's go back, or something like this. So which one is it? Well, not only do we know this is a cubic function, we know the leading coefficient in front is a negative. So this is a negative cubic function, and I would predict it would look something like this. So let me go back to my equation. I don't think I have the complete graph, and this is where you're going to have to play with your window settings to actually figure this out. So perhaps you want to zoom out, and you can press number 3 for that. Okay, and you can focus and zoom out. Oh, that looks a little bit better. But I still don't have the complete graph, because the complete graph will show all the bumps in it. I'm missing this bump down here. This time I'm just going to actually change my window settings, and maybe if I change my y min to be a little bit more negative, I'll say maybe negative 60, I'll get a better sense of what the graph looks like. Now if you think this is a complete graph, it is this the best usage of your window? Probably not. Lots of empty space to the right, empty space to the left, so therefore I think I should change my x min and max. It's way too big, so maybe I'll change it to, I don't know, negative 20. Let's see what happens if I go negative 20 to 20. Alright, this is where you kind of have to experiment too. Oh, that looks better. And if you still feel like there's too much space over here, then yes, we can go and change the x max here to, I don't know, maybe even 10. And this is once again us playing around with the window coordinates to get a nice looking complete graph. Perfect. And when you have this, you can just sketch this in your answer here. So the first thing to do is always draw your x and y axes, please. X and y. Then you should label your x minimum. In this case was negative 20, I believe. And then the maximum here was 10. The y, I think I had, what, 10? And then maybe, was it negative 60? Let me just double check that. Oh, it didn't look like 10. It looked like it was... I used 40, so 40. Maybe I guess what I should do is adjust my x-axis. I'll put it down here, haha. And then once again make a quick sketch of your graph. I wish I had a copy paste function, but I don't. But something like this probably looks pretty good. Okay, done. So key thing, indicate the scale. So I could have done the dashes, okay, and then the window setting I think is the better one to do. Okay. All right, now what else do I need to do with the calculator? Oh yes, you can actually find the zeros. Once again, what are the zeros? That's the solutions, or where it crosses the x-axis or the x-intercepts. Why do we call it the zeros? Because the idea is you're letting y equal to 0. And on your calculator here, yes, there is a function called zeros. It's under second calc. choose number 2, and then we'll quickly go ahead and help the calculator out. The calculator needs some help here. It says, hey, can you actually bound this for me so I don't have to look everywhere? So go to the left of your 0 and then press enter. Good. And then I'll move to the right of the 0 and I'll press enter. And then what you've told the calculator is, hey, I want you to look in this little region to figure out what the 0 is going to be. Give me a guess. I'll just press enter, let the calculator do its work, and done. Negative 11.64986. Now, also get used to, for AP Calculus, get used to you giving me 3 decimal places. So I'm going to say negative 11.650. That's one of my answers. Alright, so we need to find, I think, 2 other answers, and I think there might be 2 answers here close to the origin. Now, to really get a better look at this, I should go back and zoom in at the origin to really see if there's actually only 1 answer or 2 answers. I have a gut feeling that there might actually be 2. And as I zoom in, lo and behold, there are 2. So now go ahead and find those 2 x-intercepts. We'll quickly once again choose 0. We'll move our left bound to the left of the 0. That's negative. Then move it to the right. Press enter one more time, and bam! Here we go. Negative x equals to negative 0.406. And we have one more. Second calc one last time. Press enter to the left of the positive 0. Press enter for guessing. And here we go. X equals to 1.056. And there, my friends, are your 3 answers. 1, and then 2, and then a third. Done. Alright, now if you want to do number 13, where I'm asking you to find the points of intersection between these 2 graphs, what you could do is actually solve for y for the second equation. I think that's easier. And then the goal here says write the equation you are solving. Since both of these things equal to y, the equation you're solving now is negative x cubed plus 12x squared plus 9x minus 3 equals to 3x plus 5. Now, if you want to go with the method we've done before in example number 12 by solving the 0, then of course you would move everything to the left side and solve for 0. Solve using number 12. Solve using the same method as number 12. Now, if this is something you don't want to do and you want to try something different, then the different method would be to actually graph out both equations. So y1 as negative x cubed plus 12x squared plus 9x minus 3, and then y sub 2 as 3x plus 5, and then your goal here is to then find the intersection points. So I'll quickly find one of them for you, and I'm going to ask you to practice yourself. So once again, take your graphing calculator. I'm going to go to y equals 2. We'll clear it. We'll type in our new equation. We'll do the same thing, 3x plus 5. Well, negative x cubed plus... I did. Why didn't you tell me earlier? Because you couldn't, I know. The joys of video. Whoa. And once again, where is my other answer? I'm thinking I have to change my X window to stretch it out a little bit more. Does this work better? Yes it does. If you really want to see that bump, then I would change your Y a little bit more, but in the grand scheme of time, I'm going to actually just calculate using the intersect feature now. Whee! There's my curve. So get close to the intersection point. It will default automatically to the second curve. Press enter. Press enter one more time. And there we go. A better answer. Negative 1.046. So write it down. Negative 1.046. And you need to also quote the y value. Okay. And then you can go find the other two. So I'd like you to press pause, then come back and double check your answer with mine. Go for it. There are your answers. Ta-da! Okay, finally, use a calculator to solve this absolute value equation. Oh. And it's not just an equation, it's an inequality. Ooh. And then I want you to write your answer as inequality using the inequality notation and also interval notation. Let's see if you remember all these things. I'm going to ask you to use a calculator, so probably a good thing to graph out the two graphs separately, the left side and also the right side. Let's quickly do this in the graphing calculator so you can see what it looks like. If you're curious where the abs feature is, it's under math. Choose num, choose number 1, and then x squared minus 5. And then we'll clear this and choose number 4. We'll just zoom standard, and here is your graph. Ooh, there's the line 4. I'll quickly sketch that out here so we can see it. Whee! We have a parabola, and then whoop! That's y1. Then we have y2 as 4. Woo! And so you'll see that there are 4 intersection points. We need to find them. So once again, second calc, choose intersection. I'll quickly find the one to the left, and I hope you can see that there's actually symmetry amongst this graph. So if I find one, I found the other one, negative 3. Cool. So here it's, whoa, what happened there? Negative 3. By symmetry, it's also going to be here at positive 3. And I'll do it one more time. Enter. Enter. Looks like negative 1. Yes, and by symmetry, also positive 1. Okay. So the question is, what does this mean? Greater than. It means that the absolute value graph has to be bigger than the line y equals to 4. Where is it bigger? Yep, over here, in the middle, and over there. So with inequality notation, I would say my solution would be x is less than or equal to negative 3. Also, the region that's between and including the values of negative 1 and 1, and bigger or equal to 3. Okay. We always solve for x, right? So our answers are an x. This interval notation is a little bit special. I hope that you do know how to use it, because you'll see it a lot in calculus. I'll start with the middle one here, because for interval notation we have to give it the leftmost bound and the rightmost bound, and in this case negative 1 and 1. And because we have an equal sign, we want to include those. We use these square brackets. Okay. Now if I ask you to do x is greater than 3, well, the lowest value in this interval, of course, is 3. What would you say is the highest value? Infinity is the correct answer, yeah. And because I want to include 3, I'm going to put a square bracket. Now the question is, do I include infinity? Technically I should, but then the question is, how do you bound infinity? Doesn't infinity just keep going and going and going and going, getting bigger and bigger and bigger? So by convention we do not use a square bracket here, we use a curved bracket. And so understanding that, can you now help me change this into interval notation? The lowest value, the largest value in this interval. square bracket on the negative 3 because of the equal sign, and curved if it's not. Okay? There you have it. Now it's time to do your assignment.